Okay, so you should have several things in front of you. You should have a baggie full of ions. You should have a ion sheet. It looks kind of like this, ion formula sheet. And you should also have a data table. So it looks like this, data table. Alright, so what you're going to be doing is you're going to be putting ions together. And you're going to be using these little tiny ions in front of you in order to figure out how to balance out the charges. Now there are just regular old ions, atoms with a charge. There are also those that are called polyatomic, and they have a charge on them that's something like PO4 3-. That's a polyatomic. It means that it has a group of atoms that are all bonded together, and they act as a unit. They work together. Okay, so for the first problem, it says take aluminum and chloride and figure out how many cations, how many anions, what the total charge, and what the total negative charge, the formula, and the name of the compound will be. So what you're going to do is find the ion card for aluminum. That's what it looks like. And you're going to find the ion card for chlorine, and that's what that looks like. You're going to line them up, and you're going to notice that they don't form a square or a rectangle. They're unbalanced. So there is a 3+ charge here, and there is a minus charge here, and you need more minus charge in order to counterbalance that 3+ charge. So that size means that there's more of a positive charge. So you're going to need 2 more chlorine ions before you can really balance out that charge. So if you look at there, it's aluminum 3+, chlorine 3-. So what you're going to do is onto this paper, you're going to write aluminum. There is 1 cation there. There are 3, how am I going to draw this? 3, oops, that's backwards. 3 anions. And there's a total charge of 3+ from this aluminum ion. There is a total charge of 3- from all 3 of these chlorines. They add up to 3-. The formula is going to be Al1. There's only 1 of these. And there's chlorine, which is Cl, but there's 3 of them. So we need to make sure we have a little subscript 3 there. So that's the formula. Over here, for the name, we're going to write aluminum chloride. Aluminum chloride. So that's what how you're going to fill this out. Now, when you get down here, let's do one of these ones with the polyatomic as an example. When you get down here for, let's say we're going to do this guy, potassium and sulfate. Now you're going to say to yourself, I don't know what sulfate is, and a lot of you are going to make the mistake thinking that it's sulfur. It is not sulfur. It is actually a polyatomic, and it is a unit of sulfur atoms and oxygen atoms bonded together. And I'm just going to find one real quick in my stash of, here we go. Here's what it looks like. There's sulfate, SO4. Now, you're not going to know that off the top of your head, anyway. So you're going to need to use this ion sheet that's provided for you. And if you look, sulfate is a 2- on the bottom of this sheet here, and there's sulfate, SO4, 2-. Alright, so you're going to need to use this sheet sometimes in order to figure out what the ions that they're talking about in this activity are. All right, so potassium and sulfate. So here's the sulfate. Now we need to figure out where the potassiums are. So let me just find one of those. All right, potassium, there he is. So we have one potassium and we have one sulfate at this point. They are not the same size. They do not balance out. So we're going to need another potassium in order to make this a rectangle that isn't unbalanced. So let me see if I can find another. There's one. Find another potassium. I'm going to line them up, and I'm going to notice that there are 2 potassiums for every 1 sulfate. All right, so for potassiums, I need to have a 2. If I write that right, I am writing upside down. Yep, that worked. All right, there's 1 sulfur. The total charge of the positive is 2 plus. The total negative charge for this one ion is 2 minus. When we put it together, the charge or the number of potassiums are 2, so we're going to need to have a little superscript 2 there. And we're going to need to write the entire SO4. All right, over here. Let me move this camera over a little bit so you can see that. All right, so there's the formula. Because we have 2 potassiums, let's just move these over too. We have 2 potassiums and 1 sulfate unit. This whole unit acts together, and that's what's shown here on this formula. So this is called potassium sulfate. You guys impressed? I can write upside down. All right, so keep in mind that if you had needed 2 of these, that you would put parentheses around the sulfate and you would put the subscript outside of the parentheses. In this case, you do not need that because you only need 1 sulfate. But let's just make an example here of one that you may actually want to. Okay, so here's phosphate. There's 3. And we're going to have 2 phosphates. All right, we'll put 2 phosphates there. Let's see if we can balance this charge with iron 2 plus. Let's see if we got, there we go. We got an iron 2 plus here. We'll need another iron 2 plus. Let's see if we have another iron 2 plus. There's got to be another one in here somewhere. There's one. And we need one more in order to balance this out. Oh, there's one. Okay, so there we go. There's iron 2 plus. We need 3 of them, and we need 2 phosphates. So this would be iron 2 phosphate. All right? So in order to write this, we would have to do a iron, Fe, and then we would write, and there's 3 of them, so we need to have a 3. 1, 2, 3. And then we would have phosphate, PO4. But since there's 2 of them, we need to put parentheses around this whole thing and put a 2 outside of it. All right? So that's what's going on there. If you have multiple polyatomic ions that are bonding to your metal ions, you might have to use parentheses to indicate how many polyatomics you need. All right? Good luck. Ask your friends. Don't get frustrated. Do your best work. Be good. I'll see you on Monday.